Emerald Podcast Series. Research that makes a difference.
Hello, I'm Rebecca Torr and welcome to the Emerald Podcast Series. Today, we will explore the latest trends and best practices in digital technologies for the built environment. I have the pleasure of talking to two distinguished experts in the field. Professor Tim Broyd, Director of the Institute for Digital Innovation in the Built Environment at the Bartlett School of Sustainable Construction, University College London, and Professor Chime Anumba, Professor and Dean of the College of Design, Construction and Planning at the University of Florida. In this podcast, they will share their insights and experiences on how digital innovation can help create more sustainable, resilient and livable environments. Stay tuned for an engaging and informative conversation.
Thank you, Rebecca. Yes, Tim Broyd, pleased to be here. Well, I started out as a civil engineer, and some people think I still am. Some people think I never was one. But all of that said, I had an incredibly proud year, half a dozen years or so ago, as an elected president of the Institution of Civil Engineers. Now, I spent about my first 30 years in my career working most of the time in two quite large engineering design consultancies, with about half of that time as corporate director of technology and innovation, knowledge management, sustainability, those sorts of things. I've now been at UCL for just over 10 years. I work in what is now the Bartlett School of Sustainable Construction, and I'm not one to brag, but the Bartlett faculty of the built environment is pretty much regarded as certainly, if not the first, then within the top two faculties of the built environment in the world. My current focus in terms of digital techniques is really increasingly to understand how buildings are used, how we take a whole life view of buildings, how we can take a systems view of buildings, and indeed of civil infrastructure, and to teach about the benefits of taking a digital transformational approach.
Thank you very much, Rebecca. It's a pleasure to be part of this. I'm currently Professor and Dean of the College of Design, Construction and Planning at the University of Florida. And that follows from a period as head of the Department of Architectural Engineering at Penn State University. And before that, I was at Loughborough University for 10 years as a professor in the School of Architecture, Building and Civil Engineering. And I also was director of the Center for Innovative Construction Engineering, which produced a whole set of engineering doctorate graduates. So it's been an interesting set of transitions over the last few years. Currently, most of my research focus is on aspects of integration of digital technologies into buildings and civil infrastructure, focusing more specifically on digital twins. And so that is an area that is certainly growing. I have also founded an institute here we call FIBER, which stands for Florida Institute for Built Environment Resilience. And so that is beginning to tackle some of the issues associated with sustainability and resilience.
So, just to give us a background to why we're here today, and obviously we're going to be talking about digital innovation and sustainability in the built environment. Chime, could you give us some background to why this topic is so important today? And you mentioned sustainability, so maybe how it relates to the United Nations Sustainable Development Goals.
Right. I think it's now well recognized that sustainability is very important for us to make sure that our current activities and development do not in some way mortgage the future for those that come after us. And so we need to be a lot more responsible in terms of how we use resources. And so, kind of related to that is the fact that the pace of technological change is so fast and vast that there are tremendous opportunities to leverage current and emerging technologies in order to support the need to be more sustainable, but also a lot more resilient. And there are lots of different areas we can look at relating to that.
Fantastic, thank you. And I think, yes, you mentioned about the benefits of using these digital technologies. And I think it'd be great to get into some more information about that. Obviously, we've got digital technologies, that we've got loads of buzzwords at the moment. And people are talking a lot about building information modelling, digital twins, 3D printing, and the Internet of Things, and how it's transforming the way that we design and construct buildings and infrastructure. And maybe you have some recent innovations or projects that you can sort of highlight, this transformation and the benefits that these technologies are offering to us.
Yes, certainly. But I think I'd like to go backwards so I can go forwards. And just a reminder that in the United Kingdom, anyway, the trigger for the developing use of certainly BIM technology and then later allied artifacts was really that a new government was elected in the UK in 2010 and found there wasn't nearly as much money available to fulfill what it thought was its mission there as they had considered. And somehow or other, they came to the belief that transferring to a BIM set of processes for initially the development and construction of buildings and infrastructure could save them quite a significant amount of money. Now, that is what led the charge, and it was initially a mandate then from the UK government for all central government procured buildings and infrastructure. But if we look at BIM, there are maybe 6 or 7 totally different types of dimension that are theoretically available now, but industry is not using anything like that number. So just to trot through them, XYZ, three spatial dimensions. If we have an understanding of time sequencing of construction, we can add time on there to get a better understanding of how a building will be built. We can add cost on that, of course, and computers are, they're pretty good at counting and maybe not much good at other things. You can then, because BIM models deal with objects rather than just line-based thinking, you can then put on a dimension of the asset or facility maintenance. So, for example, if you put a pump room, the maintenance sequencing and requirements for pumps, for valves, for other sorts of things. And then I might have missed one, so Jimmy, please add to that. But last but by no means least, you can start to add carbon on. Right? Now carbon, just as finance over the last few years has been separated into CapEx and OpEx, right? CapEx, the financing required to build a new facility, and OpEx, the financing per year to run that facility. So you can consider carbon as CapCarb, the embodied carbon in the materials that are made to that are employed to build a building or an infrastructure facility, and OpCarb, the carbon quite often in the energy that's used to run that. Now, we don't consider those latter two parts nearly as effectively as we could. So I think there's quite a lot of work to do in, I hate to use this word, but in educating our colleagues to consider those facets more centrally. So I think a lot of sort of our work in UCL is based at that. It's based on the use of digital twins. BIM models will give you a correct, if you do it correctly, geometrical understanding of how things fit together. The move then to digital twins is about seeking to understand the performance, the in-use performance of a facility. So that extends then to the use of perhaps a significant number of sensors attached to different parts of a building or infrastructure to give you an understanding of how buildings are being used and where, for example, the energy is predominantly being used.
So in terms of sort of how it can benefit us, maybe we can sort of look at, how it does, how these different technologies contribute to sort of energy efficiency, which you've already mentioned, and the development of the so-called smart city. Maybe you can tell us about any projects or initiatives that you're involved in where these technologies are actually being put into action. I don't know how far down the track they are really. How sort of early on. So maybe you can sort of add in where you may have seen them being used and sort of maybe some of the benefits or what the potential benefits are, if not.
Yeah, it is in this understanding. So, smart has been a generic and oft overused badge for maybe the last 25 years. And its origins go back to a particular organization that reckoned that collection and analysis of data concerning facilities or maybe infrastructure routes, I'm thinking of bus routes, train routes, etc., could be much better controlled if volumes of data were gathered and then analyzed. I think certainly 20 years ago it became a much overused term, but it's now pretty much used to consider the space, I think, where the physical world and the cyber-physical world meet. So that you have a real world out there, and we can seek to understand that. We can seek to measure it in a number of ways. And increasingly, we use sensors to understand how energy is being used, where it's being used, where people tend to base themselves when they start to work in a building, when they leave a building. And we use the cyber world, the representation of the physical world on a computer to plug those numbers in from the sensors and to get as close as possible a model of the performance of a facility to the real one. Now, if we can then validate the simulated version, we can then start to optioneer about ways in which we could improve the building or make changes at least to the settings of maybe energy, maybe of where and how we allow people to congregate, so that we can get to a position where perhaps the facility itself is more human-centric, but the overall performance is better, perhaps uses less energy, perhaps provides for more throughput, if we're looking at a railway, for example, more trains per hour, etc., etc.
Fantastic, thank you. And I don't know, Chime, if you've got any sort of examples of how these technologies have been used to help create these smart cities when you're sort of planning for, change, like maybe future cities. But actually, obviously there's a lot of focus on the cities that we've got. And I don't know if you've seen any benefits that can be had by employing these digital technologies.
Yes, there are lots of benefits, and I think Tim's already talked about them, particularly as it relates to energy. I think the biggest benefit from digital twins is really the capacity to model the real environment and to then run what-if simulations of things that may or may not happen. And then when the facility is in operation, using sensors, you can capture the actual performance and the real activity within the space, which you can then use to recalibrate your initial models. And so that works really well with energy systems, but also it works well when you get into the city scale and you're looking at, say, transportation, for example. You have models of traffic, you have pedestrians, and you have different modalities of transportation. And then you have all of those. And then if you have appropriate sensing, within the city, you can actually capture these in real time. And then that can help you to make changes to your planning and even things like traffic lights, redesign of pedestrian paths through different parts of the city. So there's a whole lot you can do with that. And then the other thing that's often forgotten is that a city is made up of is a system of systems of lots of different infrastructure systems. And so the interdependencies between these infrastructure systems is not always evident because you have different groups that are responsible for the roads, the sewage, the telephone networks, and they're not always all talking to one another. If you're able to capture all of those in a digital model of the smart city, you can actually look at the interdependencies of these things. And that becomes very important in emergency situations where you have natural disasters. Because if you understand the interdependencies, then you start to prevent, you have the capacity to prevent a cascade of failures uh, across the whole city.
Fantastic. Thank you. I'm glad you mentioned about what role it has in aiding support for natural disasters, because obviously that's a big focus area, and as climate change continues, we are going to be faced with more and more disasters, natural disasters, and our vulnerability to them is going to increase. So I mean, obviously you've sort of touched on it there. I don't know in terms of like how we can sort of mitigate those natural disasters. Is there anything that digital technologies can do to help us better manage them, or when we're in that disaster, what we can do to recover?
There's a whole lot that can be done. I think from basically sensing and monitoring weather patterns, we have better predictability of the path, intensity, and potential damage that can be brought about by strong winds, flooding, or any of those natural disasters. And so that gives us a little bit more capacity to plan, for example. And then once you have those advanced warnings, you can then also start to make changes. So, for example, one of the areas being having such an extensive coastline, Florida is very susceptible to hurricanes, rising sea levels, and things like that. And so, one of the areas we have worked on is really to work with some of the coastal communities to simulate storm surge and then try to understand what infrastructure systems, what buildings are likely to be affected. And then we did that with a number of them. And then just to bring it home to the residents, we actually, in addition to the digital models, we actually created physical models that were put in the downtown areas for local people to see exactly what the impact will be. And we did this ahead of some hurricanes. And when that actually happened, our model was shown to be about 96% accurate. And now a lot of the coastal communities want us to do similar models for them. But having that predictability, and then also if you have sensors that tie to the existing infrastructure, you actually see in real time to what extent your model has been proven to be true. Another interesting aspect to this is really being able to track what is happening in real time by capturing social media posts by people within the disaster area. That is as accurate as a real time data that you can get. If somebody posts, my home is getting flooded, we have 1 foot of water, things like that. And that's all posted in social media. So some of my colleagues are tracking that. And with all of that, you get pictures, you get narratives. And if you're able to have some mechanism at the back of all of that to aggregate that and try to make sense of it, you also have the location of the person, so you can start to get a sense of what is happening.
It sounds absolutely incredible. And I think what really stands out, to someone like myself who's a non-expert, is just the fact that you can engage the community. So it's not just something that's abstract, because I think a lot of data and a lot of these technologies, even pronouncing them, it's kind of off-putting. It can be quite nerve-wracking to even understand what it means. So to actually have some engagement with residents like you have, I think that brings it home to people, like how we should invest in this. This research is really important because it can make a difference to your life, and then the data that you can get from social media, so that everyone can actually be part of the solution. I think obviously with any technology there are also challenges and there are risks, and data's obviously there's a big worry around data and privacy and security, and so I don't know if Tim could sort of join here in sort of talking around some of the worries or the difficulties around digital technologies in the built environment, and what we really need to look out for, and what you're working on at the moment.
Yeah, I mean, to be honest, in the work I do and my colleagues do, we don't see many issues of that many ethical issues or privacy issues. Security issues are quite big. I think it's important the standards that are used as frameworks in different countries account for security at least as much as they do for the process of putting BIM models together, etc. What we're looking to do in an amount of our work is to try and remove some of the barriers that potential users of these types of technologies in the industry say they have. Now, whether they actually have them or whether they're just using those as reasons. So we've been doing quite a lot of work on trust. Now, the three of us might trust each other well enough, but Jimmy, would I trust the data that you give to me? You might trust it, and it might be the very best you have, but is it right or wrong? So we've been looking at so-called distributed ledger technologies like blockchain, which has this sort of immutable chain unchanging chain of communications and connections, to see how that might make a difference. We've been looking generally at the aspects of BIM and trust, right? What does it take for someone to trust somebody else, or to trust a technique they've never used before, etc.? We're just moving on. I've got a PhD student quite recently started looking at cost-benefit analysis of using digital twins. And I think these are quite novel areas. But there are other things. That I like us to go further in. If you look at the way that buildings are built and the thinking behind them around the world, most nations will use in one way or another what they call a plan of works, which is a process scheme that goes from financing through to concept design, detailed design, construction, operations and maintenance, and then finally renewal, demolition, whatever. Now, the vast majority of those plans of work around the world stop at construction, or rather they stop at commissioning. Either they call it commissioning, which is that the new building, the new infrastructure works, or the handover from the developers to its new owners or users. If we were to look properly at lifetimes of buildings, we need to get people in the industry to think properly about lifetimes in buildings. And I think we need to try and work further to say that you can't just develop something, hand it over and wash your hands of it. And one of the good things about a BIM model, digital twin, whatever, is that it can and should become a living testament to the building itself. That if there are modifications made, they should then be reflected in the digital model, so that you have a constant and live companion. And the one other thing I'd add is also that we are still quite rudimentary in thinking about different types of systems at play in the built environment, whether it's systems within a building, whether that could be the systems used for facilities management and the systems used for controlling the HVAC and humidity and other aspects of a building, or whether it's systems and infrastructure, they're still largely on the too difficult pile. And I think there's a lot that we can do using modeling techniques to lead the way on that.
Yeah, I think, sort of looking at your vision for the future, it would be really interesting just to see where you think that this area of research should go, and maybe, if there are any more questions or problems that you'd like to still solve. What would be your vision for the role of digital technologies in the coming decade? And then obviously looking at sort of how that relates to sustainability.
Yeah, so going forward, I think some of the areas that Tim has mentioned are really very important. Security obviously is one. I think in the built environment, we don't look into that in as much detail as we should. We do have a lot of computer scientists that are looking at it. But increasingly in the built environment, particularly when we start to work more and more on these complex and highly vulnerable infrastructure systems, we need to be more cognizant of the fact that there are bad actors out there that would like to break into these systems and create havoc, be they power lines, water distribution systems, transportation networks. So I think we need to pay a lot more attention to that. Also, I think that we haven't done as much as we can on modeling and integrating the people side of it, because it's so easy to focus on the technology and get that to work right. But at the end of the day, how do you account for people's behavior in buildings and any of these infrastructure systems or in cities? So we need to figure out how to also make that something that we can track and monitor, and there are people who are looking at it at what I'll call relatively small scales, which is, for example, there are vision systems that would track people on construction sites, see if they're wearing a hard hat or not, and then inform the safety manager, things like that. But there's a whole lot more we can do with that when we start to look at kind of city scale implementations. When you start to look at how do we deal with managing emergency situations, how people are behaving in those situations, and how do we make sure that we're able to keep people safe in those sorts of situations. I think there's still a lot of work that needs to go in those areas. The technology itself, I think, is reasonably robust, but it's also, I think, on the more technical side, it's the integration of heterogeneous data and then being able to make more sense out of that and very quickly. And this is where we need a lot more artificial intelligence to kind of sift through that and then come up with really quick suggestions for what we may want to focus on rather than something else. And some things can be pretty fast moving as well. Increasingly, for example, here in the US, there are concerns related to active shooters. And so people are now beginning to look at how do you design buildings such that you can shut down certain elements and isolate the shooter once somebody presses a button. Those sorts of things. How do you identify exactly where the shooter is in a building? And how do you then make the system adjustments to protect the maximum number of people? Those sorts of things. And there are ways to do that using a high density of sensors in a building, which also can be used by other systems, such as HVAC lighting systems. But in emergency situations, you can use it to isolate different parts of the building. So there's a lot of potential application areas, but also nitty gritty sort of work on the technology adaptation and adoption within the built environment.
That's really exciting, isn't it? Just to think that, something, we're thinking about natural disasters, but actually something that's, in our modern lives, something like, protecting people from a shooter. A building can, just being able to control that building and have that technology. And I think, anyone would buy into that, who doesn't want to be safe. So maybe that's, I don't know if Tim would like to add anything to sort of, what you see for the vision of over the next decade of sort of, at the applications of these technologies in the built environment.
Yeah, we haven't really said anything about existing built stock. But if you look, for example, at the UK, and we have a legal requirement to get down to net zero carbon, brackets, whatever that is, it's still to be properly defined, by 2050, we know that we've already got 85% at least of the building stock we'll have by then. So, as time counts down to 2050, we have an increasingly urgent task to modify our current built stock. Now, I think digital techniques can have a lot to help with that. But I'm also going to plug again what I said earlier about needing to know better how people work with buildings. And I'm not decrying the great efforts made by many architects around the world. Certainly, studies of things such as space syntax allow a much greater predictability of how people move within a given space. But it's simple things like, we tend to design buildings to be used from 8 in the morning and 6 in the evening. And actually people are in there from 6 in the morning till maybe 9 or 10 in the evening. We don't make proper allowance for that sort of thing. So, yeah, I certainly agree with Jimmy. I mean, fortunately, at the moment, I've got my fingers touching wood here. We don't have the extremity of gun weaponry and abuse in the USA. But that doesn't mean to say we can sit here and just do nothing about those sorts of things.
Thank you for listening to our episode on sustainable innovations in the built environment. I hope you enjoyed listening to Professor Tim Broyd and Professor Chinmaya Number as much as I did. They gave us a lot to consider on how digital technologies can transform the built environment for the better. You can find more information about my guests and a transcript of the episode on our website. I'd like to thank my guests for joining me and sharing their insights and experiences. My thanks also goes to podcast producer Daniel Ridge and the studio, This Is Distorted.